All right, this week you're doing exercises 4-1 and 4-2 in adhesive. So let's take a look at what we got going on there. As you get logged into adhesive, their website can be slow at times, and I'm sure if it's something about being on campus and being home, etc. But if you're experiencing some slowness with the site, that's common. I'm not sure what's going to be like this morning, so we'll just kind of see how it chums along. When we're in modules, you'll see the lesson 4 modules, what we're working on this week. And we're, as far as time goes, we certainly are not going to get through every single part of 4, just because it's really extensive. It goes on and on and on. And I'm just going to dabble in different parts of lesson 4. So if you're working from home and you're working ahead with everybody, you're welcome to go ahead and do every one of these activities if you choose to. But I'm only going to assign a handful of them. Mostly because if I minimize this here, we have to get over Unit 5 and also Unit 6 before this semester is over. And if you've noticed that when you take a look at where we're at as far as the course goes, we're already on week 6. So we only go to 9 weeks. So we got 3 more weeks to go with this. And next week is week 7. So it would be 7, 8, 9. So there would be 3 more weeks to go. Which reminds me of a joke. You know why 6 is afraid of 7? Because 7, 8, 9. Get it? 8, 9. Anyway, so let's get to Unit 4 here. First part, it starts off as an introduction to Python. Huge fan of Python. It's one of my favorite programming languages. These are not the ones that you find out in the Everglades, by the way, that they have those shows where you can go and hunt them. This is a programming language. It's a very simple programming language, in my opinion, and also very, very powerful. So if you ever wonder, like, oh, well, what would you use? Let's see what runs on Python. There's just a few software programs you might recognize in this list as far as what Python is programmed for. In that case, YouTube. I'm not sure if you guys ever have rolled across that website before and watched a couple of videos or two, but YouTube runs off of Python. Dropbox, this little app called Google, that runs on Python. Instagram, I'm doing it for the gram. Okay, that's another one. Spotify, and I'm not sure how many of these you guys actually use, but my guess is at least one of these you've probably come into contact with. And you need to understand that these programming languages are so powerful that they run almost that entire site. And they're easy too, which is the best thing out of all of it. So those are some of the programs that run on Python. When you start taking a look at how complicated Python, I think you'll find that it's less complicated than Scratch, in my opinion. So we take a look at Scratch. This is what the code looks like. You've got if, some kind of a thing here, then. So when you take a look at what that code looks like in Python, it shows up as if there's a particular condition, it's going to do something, else it's going to do something else. So I always love to use my printer in the background here, the back of my classroom here for my example. That printer sits there and it does nothing every day because I never print. But it's actually running. Because if the condition is there's no print jobs, then start a timer and go to sleep. And that's what it's doing right now. It's sleeping, and it's been sleeping for at least a week and a half now because I haven't printed a single thing. And it will stay like that forever until, the power goes out, kind of like in Texas. And then basically, if you think about it, any computer system that's built or made, there is never a such thing as 100% uptime. They're not. They might have battery backups. That's great. Your battery is still up, but the phone company, they're probably lost power of some kind, so they're probably going to glitch too. There are transformers that go out. I live in La Mesa here, just probably like a lot of you. The power went out at my house last week. It was out most of the day, kind of came back and then went away. And everybody has to go through that. So there's always going to be some kind of a reboot that happens at some point in time. Your software is never up 100% of the time, no matter what it is. There always has to be a patch that's installed and run. So it's never up all the time. So every time your system restarts, like my printer will have to restart eventually when the power goes out, it's going to have to load its operating system again. And after that operating system loads, one of the first things it's going to do is going to look if there's a condition for something to print. And if there isn't, that timer is going to start, and in about 45 seconds, it's going to put itself into sleep mode. Else, it's going to print out all the things that were sent to it while it was asleep. So, or while the power was out, or while it was rebooting, whatever that situation is. Okay, so the code reads really easy. When you take a look at the second if condition, this is where you have a multi-if statement followed by an else statement. There's nothing more complicated here except that if that condition is that condition, if it's true, then it's going to do something, and it's going to do more of something. So this could be print one paper, or it could be print multiple papers. Maybe I had a whole classroom of kids sitting in here, and they all hit file print at the same time. So not only is it going to print my thing that I sent, but it's also going to print all of those. And it's going to keep doing that kind of indefinitely until it gets to a condition where there is nothing. And then that's when you get to the else do something else. So if there are no more print jobs left, you can guess it's going to start that timer and go right back to sleepy sleep is what it's programmed to do. So there's a program they use here, Python compiler they use called REPL-IT. REPL-IT is a pretty simple application, and what it is, it's an online compiler for Python is what it is. When you take a look at the two different programs, they're just showing you how they're similar. In this case, you've got the little flag for start and the stop sign for stop and scratch. In Python, it's run and stop are those two icons there. So those are the primary ones you're going to run into. Each way of outputting text, if you're in Scratch, you just pull down this blue box, say hello. In Python, you're going to type print, parenthesis, quote, hello, and it's going to output whatever is inside those quotation marks to the screen. This is exactly the same as Java. This is exactly the same as Perl. This is exactly the same as many different programming languages. C++ is a little bit different. C++, instead of that print statement being like that, it's actually cout is what it says for C++. But almost every language, once you learn one language, almost all of them are the same. So it's really easy to pick them up. It's not a whole lot of extra learning goes on. So once you start learning one language, you'll know pretty much how all of them work. As you scroll down here, there's a few more examples here. When you take a look at this one, these are repeat command in Scratch. We call it a while command in Python and in every other programming language, by the way. That would be the same in C++, the same in Java, the same in JavaScript. And while, now how this is going to read, while x is greater than or equal to y, it's going to do something. Okay, so while a certain condition exists, okay, or it's greater than or equal to that particular y, whatever that value is, it's going to do something. Who knows what it's going to do? The next one, Scratch says repeat 10 times. This one's a little more complicated. This one looks kind of weird in Python. So whereas you're going to, for I in a range of 10, it's going to do something. So the range is how many times it's going to do it. Actually, this one looks a little better in Scratch than it does in Python, but they do exactly the same thing. And this is also the same in every other language as well. We've got players with a couple of open brackets there. If you could imagine, if you had players, you would actually put their names inside those brackets with commas. Players append, if you added things to the players. All right, creating a REPL.it account. When you go there, it's going to ask you to start up an account. When you do, probably, let's go to sign up. We'll do that one. And it's going to take your regular good old Google single sign-on. So when you click on your Google single sign-on, that's going to set you up with your REPL.it account. Hey, look, it even knows who I am. So set your username, Patrick Domingo. Next. Yes. Skill level, I'm brand new, which is a joke, but we're talking about, I'm interested in learning. And then next. And we're interested in learning Python. And I think that's probably as much as it's going to let us do here. So that's how you get the account set up. When you get back to Adhesive, we're going to get into it in the next activity. But for now, let's take a look at punctuation. So punctuation matters. Here's the sign, it says attention, toilet only for disabled, elderly, pregnant children. That's impossible. If you're a child, you're probably not pregnant. And you're probably not elderly either. So when you're trying to meet any one of these conditions here, if you programmed a robot to stand in front of the toilet and only admit disabled, elderly, pregnant children, it wouldn't let basically anybody in. No one would get to use that restroom. So you had to have commas in here because it has a totally different meaning to it. That's how computers work. It's the same thing with the next one here. They got this image of this person here. Let's eat, children. Okay, means totally different than let's eat children. You have to understand that computers are dumb. It says it right here. They do not get, they do everything literally. They do not understand what it is that you're trying to say if you don't set it up exactly like it should be. When you take a look at punctuation, Scratch is going to look one way, the Python's going to look like this. Python's very sensitive to indentations, by the way. So that tab over that you did here, you have to do that. Otherwise, your code will not run correctly. And they talk about there in this indentation as far as it makes it easier for you to read as well. But Python flat out, it won't load unless you have it correct. The AP pseudocode looks very similar to the Python. Not much difference at all, so I don't think you'll have really any trouble with this. But going from scratch to Python is kind of hard, and there's a lot of AP curriculum that doesn't even teach Scratch initially, which I think might even be better for most students because this is not difficult to read. I mean, if you go through and read this here, what is this? Well, the input is greater than 0, so any number bigger than 0. If the input's equal to the answer, for I in range 10, print hooray. So if it guesses the right number, it's going to print out hooray. Who knows what that number is? It's in a range of 10, so there's 10 chances. So if the input is the answer, it's going to print out the answer. If the number input is too big, it's going to say that number is too high. Otherwise, it's going to say if its answer is less than that, then it's too low. And it's going to keep outputting those again and again and again until you actually get the number. Case sensitivity. When you take a look at this, when you see yes, 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 okay, this all looks the same to you, right? I could write this several times in a text message and send it to you, and you would know that I meant to say yes every single time. But to a computer, every one of these are different. The reason why is because if you think back to when we did that binary activity where we converted letters to binary, remember the computer only sees ones and zeros. It doesn't see yes, yes, or yes. It sees strings of ones and zeros. And every one of these strings here, these 3 strings, they're all totally different. So you have to understand if you have your capitalization off, it will not accept it. All right, now we're going to get to the actual what went wrong activity here. So when you go to this program, there are some spotlight pages here. You can ignore that. And then we can click on code here. And then we're probably going to have to edit this is probably what we'll have to do. Yep. Oh, no, can't do that. So that kicked us out. So what we're going to have to do is, I think, let me try that again. So I think what's supposed to happen, because I did this earlier. And if we go and we try to run this code, which there should be a run thing here. Oh, I think we have to fork it first. There we go. So now we get into the console. So in the instructions, it kind of talks about forking it. And it's kind of like, that's kind of a weird way to talk about working on code. Fork you. But that's exactly how you do this. So when you get into this, now you have an option to run the program. So when you go to run it, it's going to tell you main.py line 12, you lose. And it doesn't like that. That little caret underneath that, lose, that's telling you that there's an error there. What could be the error? Well, you need to go and start from the very top and take a look and see what the errors are. And I can tell just by glancing at this for like 2 seconds that score and score are different. So these should be the same. And if you're going to initialize score with an E, then that's definitely something that you're going to want to do there. So that's probably one of the 5 errors. Not that I'm going to give you all the answers to this, but that's one of the 5 errors. So as you go through this, I can fix that one and I can rerun this. It still thinks you lose is wrong. What could that be? That's for you to figure out. So go through and run this application, figure out what the problems are. When you get done, you're going to take your code that you fixed it and copy and paste it into here and submit that, and then move on to exercise 4.2, more Python basics. Okay, there's a PDF of these slides, and they're mostly talking about comments. One of the things about comments is here we got an example comments here. So Ada Lovelace, she wrote a program that says hello world. That's what everybody does for their first Python program or C++ program or whatever language it is. That's super common. All this is in gray. This tells the human being that these are comments, and it also tells the computer not to compile these. If you didn't have these quotation marks here, the computer would try to compile these and it would error out. So what you have to do is you have to go in and make sure you give comments there that the computer does not compile. And that's mostly for you to remember how you went in and did something. Because I can guarantee you, if you write something a year or two later, when you have to take a look at it again, if you have to take a look at it again, you'll forget why you had that line of code there. When I worked for the San Diego Zoo and I built them a huge database on the animals that were in the children's zoo, about 5 years later, they asked me to come back out and take a look at it and update it with new animals. As soon as I looked at the code that I had there, I was lost. I'm like, oh man, why do I have this line of code here? So the comments, they help you from getting stuck into those particular problems so you can remember exactly why you had that there. More common now is that you're going to work with a team of people anyway. Okay, you're not going to be just building code all on your own. Okay, you're going to have like 3 or 4 other people working on the same kind of thing you are, and you need to let them know what changes you made or what line you made and what that line does, so that way they know what it is, so there's no conflicts. Okay, because that's very common to happen. So make sure you use comments. That's what they're talking about, using double quotes for going through and doing multiple line comments in your code. And trust me, you will thank yourself later on, because you're going to look back at it, even if it's a couple of weeks after, you're going to look back at that code and be like, now, why in the world did I put that there? Okay, and I'm sure there was a reason that you did it, but for you to actually remember all that, that's putting a little too much stress on your head there. So use the multi-line comments. They show you some examples here, also in the AP code, working with a few variables. There's some AP pseudocode. There's typecasting. When you talk about typecasting, this is talking about what kind of numbers to use. When you're programming in Python as well as other language, you need to tell it exactly what kind of number you're going to be using so it knows what to expect. A general integer, an int, that's a number that is a whole number. So right down here where it says 100, okay, that's a whole number. It's not a decimal pointed number. And you might think, okay, well, why would I ever use just a regular number like this? Well, the reason why is because if you're calculating something like someone's birthday, okay, you're never, 15 and a half years old. You're not 15.5. People ask you how old you are. You're either 15 or you're 16, or you're 50, or however old. You tend not to use a decimal point there. So that is perfectly acceptable. When you're doing dates, okay, there is no date that shows up with a decimal point. So that's inappropriate to use it in that situation. But if you're going to launch something to freaking Mars, you're going to need a really big number that's going to need some decimal points, because that decimal point could be the difference between your spaceship landing or crashing. So that's where we're going to use float. And just so you have an idea about it, Mars is about, I forgot what the number was. I want to say it was like 28 million miles away, whatever that number is. Well, that's probably not going to be a whole number. It's probably going to be 28 million.2 or something like that. So this is where you hold that. A bool, that's just short for a Boolean value. That means it's either true or false. It's yes or no is what it is. So that's just short for Boolean. And then the last typecast that they have here is string. A string would be just a series of text. It could be a name. It could be basketballs. It could be whatever. That's just telling the computer that, hey, this is a string and not a variable. Because you might have a variable basketball player, or you might have a variable of basketballs. But if you're trying to tell someone, we have 25 basketballs, you have to tell the computer that the basketballs word is actually a word and not a variable, because it outputs differently. In order to get those to output correctly, you have to use what's called the concatenation operator. So this is your word of the day. And I can almost guarantee not one of you have used the word concatenation in your life, because it's a computer term. It's only used in programming. So you wouldn't run across this on the AP English test. Probably not in junior high vocabulary. You probably have never seen this word before, because it only does one particular thing. And what it does is it joins strings together, is what it does. So the computer's a little clunky when it outputs text. With this one in Scratch, it says set name to Carly. That's exactly what you're doing here in Python, except this equal sign is not the equal sign. The equal sign is the assignment operator. So how this really reads is Carly is being assigned to the variable name. That's how this reads, and you read it from right to left. So when you take a look at the next thing here where it says print, quote, hi, space, end quote, plus, okay? But this is not a plus. This is concatenation operator, name. And what was our variable there for name? Carly, right? So this is going to be Carly, concatenation operator. And then we have the quote start up again, comma, space, nice to meet you, end quote, parenthesis. So the output here with these three little arrows is hi Carly, comma, space, nice to meet you. So that's how this outputs. So the concatenation operators, you don't see them. You don't see those pluses there. And if you're not good at math, then this makes it easy for you, like it does for me, because I don't have a problem seeing that's a concatenation operator. But some of you are going to look at that and be like, oh, that's a plus. We're adding something together. No, you're not. You're just inserting text is all you're doing and putting those strings together. So you're not really adding them together. So you have to be a little bit careful with that. That's not a plus. We're not adding things together. We're joining them. That's what the concatenation operator does. The next one, comments and outputs, you're going to go back to that REPL.it site and go through and run their code here. And they're going to ask you to install some comments in there and then turn in your program as a link this time. As you do that, you just send me the link. So it should be pretty easy. I don't think any of this stuff is super complicated. You should go through it. Just, stick with it. Don't just give up and think like, oh, I can't figure this out. Grind on it a little bit. See if you can figure the answers out. So have fun and see you guys next week.